In this video lesson, we're going to be taking a look at ionic compounds, and we're specifically going to be looking at writing formulas and then naming the compounds from the formula. So before we get started, just a couple reminders. Remember that for ionic compounds, we're essentially looking at cations and anions, and so make sure that the charges balance out to be zero. I'm going to show you two methods that we can use to write formulas and then eventually name formulas, and that's the Tchart method and the crisscross method. The crisscross method is definitely faster, although with the crisscross method there's a couple things you have to watch out for, and if you miss those things you can definitely make mistakes. The Tchart method takes a little bit more time, but it's definitely helpful because it's visual and you'll never experience any errors so long as you're doing it correctly. You won't have to check for anything. You'll always get the correct answer. And so let's go ahead and take a look at some examples. Okay, so on this screen we're looking at three ionic compounds, and by the way, I know they're ionic compounds because if you take a look at the beginning element, every single element that starts off this compound is a metal, and so that tells me that these are ionic. But nevertheless, we're given the formula name, we're asked to write the formula. So the first one we're going to look at is potassium nitride. Alright, so I'm going to show you the Tchart method, and then I'm going to show you the crisscross method with another example. Okay, so let's take a look at the Tchart method. So how you do the Tchart method is you want to take a look at the metal and the non-metal, or the cation and the anion, and you want to write out their symbols. Okay, so for potassium is the letter K, and nitride comes from nitrogen, and that's going to be the letter N. And then what you're going to want to do is you're going to want to separate them by a Tchart, so something like that. Now you want to write up the charges, and so potassium is an alkali metal, it'll always be +1, nitride is going to be -3. Whoop. Alright, so the first thing you want to do is you want to draw a single atom of both. Okay, because you know you need at least one atom of each in order to make this work. Alright, so every time you draw an atom, write the charge on the inside of the atom. And so one potassium is +1, one nitrogen is going to be -3. Alright, so now that I've got that, take a look at the charges and ask yourself, does that cancel out to be 0? And the answer is no, the net charge right now is -2. And so we need more positive. And so I'm going to add another potassium. Alright, doing so now makes it a net charge of -1, so I'm going to add one more potassium. Alright, and now doing so, we can see that +3 and -3 cancel out to be 0. So to go to write the formula, that's going to be, the cation is always written first, so we took 3 potassiums, and it took 1 nitrogen. So K3N would be the formula here. Now for the next one, aluminum oxide, I'm going to show you the crisscross method, so you can see how that one works. So for aluminum oxide, same thing as before with Tchart, we're going to go ahead and write out the symbols and their charges. So aluminum is Al, and then oxide comes from oxygen, and that's O. And now aluminum is always +3, and oxygen is always -2. So now what the crisscross does is you want to ignore the sign, so don't worry about the positive and negative, just look at the number, also known as the magnitude. And what you're going to do is you're going to crisscross those charges down to be the subscripts. So if 3 goes with aluminum as the charge, it's going to be the subscript for oxygen. And if 2 is the superscript or charge for oxygen, that's going to go down and be the subscript for aluminum. And so that is going to go ahead and get rewritten as Al2O3. Now the only thing you have to check for with the crisscross method is you need to make sure that the subscripts are written as their lowest whole numbers. In other words, if it can be reduced, you need to reduce it. So 2 and 3 cannot be reduced any further. That's like saying, can you reduce 2/3? And the answer is no. And so that actually is the correct formula. So for the next one, manganese 4 sulfide, I'm going to actually do the crisscross method because I want you to see something. So manganese, be careful, manganese is Mn, and the Roman numeral 4 here indicates that that's the charge for manganese. And then sulfide comes from the element sulfur. And I know all of these are elements because they all end in "ide." And so that tells me that they're elements versus a polyatomic ion. And sulfur has a charge of -2. So now I'm going to crisscross these charges, and so the 2 will come down here, and the 4 will come down here. And so that means that my formula with the crisscross is going to be Mn2 and then S4. Now I have to look at that and say, can those subscripts be reduced? And the answer is yes, they can. And so that is actually not the correct formula. We would have to reduce those further to be MnS2. And so that would be the correct formula there, not this one. If you had done the T-chart method for that one, you wouldn't have gotten the incorrect answer. And so just make sure with crisscross that you checked for those reductions. So now let's take a look at the same thing, only now we're going to throw some polyatomic ions into the mix. So this first one, we have iron 2 phosphate. So from now on, I'm going to use crisscross, but feel free to use T-chart, please, if that makes you feel better. All right, so iron is Fe, and it has a positive 2 charge. And then I know this is a polyatomic ion because it ends in 8. Most polyatomic ions will end in 8 or ite. And so phosphate is not just phosphorus, but instead it's actually PO4. And then the charge for phosphate is going to be -3. So if I crisscross my charges, 3 comes down here for the iron, and the 2 goes down there for the phosphate. So if I rewrite that, I'm going to write iron needs 3 of them. Now, since there's multiple polyatomic ions that I need, I'm going to go ahead and put this polyatomic ion phosphate in parentheses. That way, it doesn't get confusing when I say that we need 2 of them. And so that would be the way we would write iron 2 phosphate. Let's take a look at the next one, aluminum chromate. So we have aluminum. Aluminum has a positive 3 charge. And then chromate is CrO4 with a -2 charge. Oh, sorry about that. All right, so the 3 is going to come down here for the chromate, and the 2 is going to go down there. And so we have aluminum. Oh, let me draw an arrow there. There we go. Aluminum needs 2. And since I need multiple chromates, I'm going to put it in parentheses, CrO4, and we need 3 of those. And I didn't say this on the last one, but 2 and 3, or 3 and 2, those can't be reduced any further, so we're good there. Now this third one is a little different because the polyatomic ion here is actually a cation. Ammonium is a polyatomic ion. That polyatomic ion is NH4. It's one of the few polyatomic ions that actually has a positive charge. Ammonium has a positive 1 charge. And it's bonding with oxide. Now notice the IDE. Most of the time IDE means that it's going to be just a regular element, so oxide comes from oxygen, and oxygen has a -2 charge. So we're going to do our crisscross. The 2 goes down there for ammonium. It's assumed to be the number 1 there, so the 1 comes down here for the oxygen. And so writing that out correctly, it's going to be NH4. Now we need 2 of them, so I'm going to put that in parentheses. Anytime you need multiple polyatomics, put it in parentheses. So we need 2 of those, and then the oxygen only needs 1. And so that'd be the correct way to write ammonium oxide. So now that you feel comfortable being able to write formulas, let's go the other way. Most ionic compounds are going to be binary. I shouldn't say most, but a lot of the time it'll be binary. And what does that mean? Binary just means that it has only 2 elements. So that means you're not going to be dealing with a polyatomic ion. You're just going to be dealing with a simple metal element bonded to a non-metal element. Sometimes, however, you will have a polyatomic ion in there. And anytime you have a polyatomic ion, that compound is known as a ternary ionic compound, meaning it has 3 elements in there. Because most polyatomic ions are made up actually of 2 elements. And so 3 elements total in the entire compound. So the way we name ionic compounds is just like we named the individual monatomic ions. So we're going to name the cation, and then we'll name the anion, but we're just going to eliminate the words ion from the name. Once again, watch out for polyatomic ions. So if you recall, when you name a cation, you just name the element and then the word ion. So sodium ion, and then the anion always got its ending changed to "ide," and so bromine became the bromide ion. But when you put them together, you're not going to say the sodium ion bromide ion. You would get rid of the words ion, and so the name becomes sodium bromide. For the second one, you have calcium ion and fluoride ion. Never mind the fact that you have 2 fluorines. It doesn't matter. It's still the fluoride ion. So the name would be calcium fluoride. Third one is the aluminum ion matched with the nitride ion. Doesn't matter that there's 2 and 3. It doesn't make a difference because we already know from the name how many there will be. So it's just aluminum nitride. The last one, however, it has a polyatomic ion. Don't get freaked out by it. Don't start naming this last one, carbide, hydride, oxide ion. You don't want to do that. Whenever you see multiple multiple elements, that should be a key indicator that that's a polyatomic ion, and that's the acetate ion. So we wouldn't say it's the strontium ion acetate ion. We would just say it's strontium acetate. So let's just do a few examples where we're going the opposite direction. So we have the formula, we're asked to write the name. All right, so this first one, we have K is potassium, and it's the potassium ion, but I'm going to actually not even write the ion because I already know I'm going to get rid of it. Sorry about that. It keeps wanting to advance my screen. So potassium, and then SO4. Right away I see, okay, multiple elements here. Specifically, there are 3 in this compound, so that's a ternary compound. So that SO4 probably is some sort of polyatomic ion. And it is. It's sulfate. I think if I write in cursive, it won't advance to the next slide. All right, the next compound here is COOH3. So once again, I have 3 elements in here. I have CO, which is cobalt, oxygen, and hydrogen. So once again, that's telling me most likely I have a polyatomic ion in here. And I do. It's OH. That's the hydroxide. But first we have to name the cation. So cobalt. Now, notice where cobalt is on the periodic table. Cobalt, so annoying. Cobalt is a transition metal. And so remember with transition metals, we need to figure out what is that charge. So I'm going to put a parenthesis here because we have to put the Roman numeral to indicate what the charge is of cobalt. So we'll come back to that in a second. But we're going to name OH. Doesn't matter that it's 3. We're still going to name OH whatever it is, and that's hydroxide. Hydroxide is an interesting polyatomic. It is one of the few polyatomic ions that does not end in ate or ite. It ends in ide. But don't get fooled when you see hydroxide. That's not an element. That is a polyatomic ion. So with the polyatomic ions, with the transition metals, to figure out what charge they have, you have to look at what they're bonded with. And so if I look here, I'm going to actually show you 2 ways you can do this, the crisscross method or the Tchart method. So it's not written here, but I'm going to write the number 1 there, indicating that we have 1 cobalt. So if you do a reverse crisscross and bring those subscripts back up to their charges, that would indicate that hydroxide, because it's written second, it's the anion, so it's negative, but that would mean it would be a -1. And that is actually correct. Hydroxide is -1. So the 3 comes up here for the cobalt. And remember, cobalt is the cation, and so that is going to be +3. And so that means that our Roman numeral here is going to be 3. The other way you can do it, and I'll do it off here to the side, is the Tchart method. And the Tchart method actually is very useful here. It's very good visually. So cobalt is my cation with the unknown charge, and hydroxide is the anion, and I do know what hydroxide is. Hydroxide is -1. And according to the formula, because remember now you know what the formula is, there is 3 hydroxides in this compound. So I'm going to draw 3 circles to indicate that I need 3 hydroxide groups. Each hydroxide is a -1. So that means the total negative charge is -3. Remember, ionic compounds have to equal 0. And so that means the total charge on the cation side between all of the atoms must be +3. Well, how many cations did I need? According to the formula, I only needed 1. So if the total on the cation side is +3, and that's spread out over 1 cobalt atom, that must mean that cobalt actually is +3. So that's another way you can do it. It doesn't matter which way, reverse crisscross or Tchart, you're still going to get the same answer. So this last one, I'm going to actually do crisscross, but I'm going to do it on purpose because I want you to see something. So let's write out the name of this cation. Mn is manganese. And manganese is also a transition metal, just like cobalt was. So we're going to have to put a Roman numeral in parentheses. So let's put that here to remind myself later on to put that in. Now, we do not have a polyatomic ion. We just have a regular anion element here, sulfur. So that's just going to turn to sulfide. Remember, most of the time, the IDE ending is reserved for just regular elements. Okay. And so now we need to figure out what the charge is for manganese. So the reason why I'm going to do reverse crisscross is because I want you to see something. So based on this formula, I'm drawing in the ones, indicating that there's one of each. So if you do reverse crisscross, you might be tempted to think, oh, okay, manganese must be +1 because sulfur is -1. But ask yourself, is sulfur actually -1? No, it's not. It's actually -2, remember? So, oh, that looks like -12. -2. So then that means in order for this to balance out, manganese must be +2. But why is it that it wasn't written as Mn2S2? Well, the reason why is because remember with crisscross, you have to reduce the subscripts. And so if you were to do the crisscross with this, you would have gotten Mn2S2, which would have reduced to MnS. So the charge here for manganese is actually 2, not 1. Let me show you real quick how you would have gotten the right answer with Tchart, and you wouldn't have had to worry about checking for that. So Mn has the unknown charge, but sulfur we know is -2 based off the periodic table. According to this formula, how we saw it, it took one atom of each to make it balance out. And so if sulfur is -2, that must mean manganese must be +2. And so you see how with the Tchart you would not have gotten it wrong. You don't have to check for those weird exceptions, whereas with crisscross you have to.